Silence, change your mic.
So how do we go about subtracting integers? So I'll develop the idea from the beginning, just so that everybody gets another chance to look at what the issue is. Okay, so you have to understand what is the problem with this, and then you will see the solution. So let us start with some simple ones. Let us say that I have 5 negative beads. So I take 5 negative beads, and then from that I'm going to subtract 2 negative beads. Okay, so that's easy enough. I remove 2 negative beads from 5, so the answer that will be left is -3. Now in terms of doing the operation purely with numbers, you can also say -5, and there is a small quirky thing over here, and some of you are aware of it. You had mentioned it last time. Yes?
So -5 -2 equals to -7, no?
No, wait, just watch. Well, you saw it, right? How do you account for this? I have -5, correct? I am supposed to remove -2 from this, correct? So I removed -2 from this. So what is left? -3. Okay, so the thing is over here, it is confusing because you may think, well, -5 and -2, shouldn't it make -7? But wait, isn't that adding integers? If you have -5 and you have -2 and you have to add them, this is a plus sign, say, then you get 7. 1, 2, 3, 4, 5, 6, 7 plus, isn't it? So how can plus and minus give you the same result? That is also absurd, right? In mathematics, we don't get that. If you have a sum with a specific number, there is -5 here and there is -2 here. Then if you add them and you get 7, and you subtract them and also you get 7, then there is something wrong. Mathematics doesn't work like that. Okay? So therefore, when it's minus, that does not mean that there is another -2 over here. But what you're saying is, I am removing 2 from this. So you don't remove 2 from this, you remove 2 from this. So what you are left with is 3, -3. I was just going to explain in terms of the operation itself. One easy way to remember this, which is of course not very easy for everybody, but if you practice it sufficient number of times, you get it. They say, and I was told this when I was in school too, and I didn't like it very much, but I used it. They say minus and a minus, when it comes together inside and outside the bracket, what happens to it?
Plus.
It becomes a plus sign.
Yeah, you get a plus. Yeah, you get a +2. Okay, and now this is not really mathematics. Okay, you can't magically turn a minus and a minus into plus. You should know why that happens. Okay, so if you say it like this, then what happens? Just one moment, let me finish what I'm saying, and then you can ask your question. Now you may again ask, well, how do I remove? How do I add 2 to a negative number? Again, they told us a rule. They said, well, if you have a larger number which is negative and a smaller number that is positive, then what you have to do is you have to subtract the 2 and give the sign of the larger number over here. I'm sure some of you have at least heard of this. Okay, all that, to me, when I was in school, honestly, it was very confusing. So they said, do this as 5 minus 2, but I was thinking, why should I do it as 5 minus 2? There's a plus over here. But they said, no, use this sign. Okay, so then they said the answer is 3, but it's not just 3. You have to give the sign for 3 as the sign of the larger number. And I didn't find it convincing. I had to learn it because I had to do tests and exams and pass them to go to the next class. So I just did what they told me to do, but it kind of left me very confused for a long time. I didn't get clear about this until I was in class 8, class 9, and sometimes I was doubtful even at that point of time. But I knew how to use the rule and I used it, but I didn't like it that it was not logical. So to answer this question in a logical manner, at least if you accepted this part of it, which itself is not easy. Somebody then helped me out by drawing the number line. I don't know if it was my dad or my tuition teacher. Yeah, I took tuitions for maths. Unfortunately, I had to. So she said, look at it like this: 1, 2, 3, 4, 5. And then let's also put 5 on this side. 1, 2, 3, 4, 5. So you had 1, 2, 3, 4, 5, and these were all positive numbers, 0, and then negative numbers. So it's -5. So come to -5. Okay, that's where you are standing. Okay, let me put it like you are standing here. And you have to move +2 from there, which means that you have to move towards the positive direction. Okay, it's +2, which means you have to move towards the positive direction. And how many times do you have to do that? 2 times. So you can now choose to do it in 2 steps, in 2 hops. You can do 1 hop to here and then another hop to here. 2 hops. And then you are left where? Where will you be standing? -3. So that way it worked out. Can you just mute yourself, please, if you are not speaking?
Will you go back if you get to minus? Will you go back?
There's 1 hour in full charge.
Okay. So that is how finally I kind of got okay with this. But again, this minus and minus becoming plus, that was something that was not satisfactory for me. But if you think of it in terms of minus beads and then removing 2 from that, that made it pretty clear that it is -3. Okay, so it kind of logically sits. And what is the correct way of learning it? Well, I don't think there is any correct way of learning it. Basically, whatever logically sits well for you, because mathematics is all about logic. There should be nothing illogical in mathematics. Okay, so whatever sits nicely logically in your mind, even if it is minus and minus plus, and -5 + 2 is 3 with the larger number sign as the negative sign, it's okay with me. I'm fine with that. That is one method. You like the number line method? Take the number line, work it out from there, start from one point, look at the sign and say which direction you have to move and how many times you arrive at the answer. That is also good. If you like the beads idea, no problem. You yourself collect a set of beads. Sorry, I'm having a lot of noise.
Shivas, mute yourself.
Okay, I muted everybody. Please don't unmute yourself again. Okay, so then keep some beads with you, 20 beads, 30 beads, whatever you want. You can also put 50 beads. If you don't have beads or beans, you can take dal from the kitchen and rice grains from the kitchen, or you can use your, if you have Lego sets, you will have those tiny 2-piece Lego pieces. You can use 2 different colors, red and blue if you have it, or yellow and green, whatever you like. Just so that initially while we are doing this, as in terms of class 7, you use those to make sense of what exactly you are up to. Okay, and slowly you will find out that as you keep doing the operations, you will yourself understand how to just look at the numbers and do it. What we need is from a kind of an drawing or activity based understanding of what you are doing, to just being able to do it directly with numbers without the activity or the drawing required. Okay, but initially if you want to do that, you are welcome to do that. It takes a little bit of time, doesn't matter. You may do things a little bit slowly. It's perfectly all right. Keep doing it. One day you will just find that you don't need those things anymore. Then you can get rid of those. It's like learning to ride a bicycle. You have those trainer wheels in the side, which makes an awful amount of noise, but then it helps you because you don't fall off. So once you have learned how to bicycle balancing in just 2 wheels, then you can get rid of the trainers. Until the trainers are there, maybe your friends have learned it already to bicycle on 2 wheels and they are whizzing past you, but you have these trainer wheels, so you're going a little bit slowly. It's okay, because it would be stupid to remove the training wheels when you don't know how to cycle. If you remove the training wheels, then you'll fall down. Then you will become scared. And then when you become scared, you don't want to do it. If you don't want to do it, then you're not going to learn. Okay, so for the time being, use the beads, use the drawing, use whatever method you want. Go slowly, does not matter, take more time, no issue at all. And slowly you will see that automatically you will get rid of the pain. You don't see adults sitting around with beads, except me, adults sitting around with beads and number line to do subtraction of integers, right? Later people learn how to do this and they have no problem using this method. Okay, so now moving on, this is easy enough. In a way, you get the answer as -3. But and of course the same thing applies for positive numbers also. So when you have, let's say, +7 and you want to subtract 3 from it, +3 from it. Okay, this is again very simple. You take 7 beads if you like it from this thing. So you have, did I get 7? Yeah, I got 7. And then you remove 3 from it. So this is the operator, right? So it tells you what operation you have to perform. Remove 3 positives. So I removed 3 positives and I'm left with 4. That's again very straightforward, nothing very confusing about it. And you can also show it like this: +7 minus and plus. Actually the rule is very simple. Minus and minus makes a
Plus.
everything else makes a minus.
Minus and plus minus.
Except if you have a plus and plus. Okay, so minus and plus makes a minus. That's what they say. I don't like it, but it's okay. I don't mind it. And you can say that 7 minus 3. Remember, this is the operator. It's not the sign for this number. Then you say if you remove 7, if you remove from 7 3, you get 4. So that's another way of doing it. If you like the number line approach, then you need 7 now, and you need 7 in the positive direction. 1 2 3 4 5 6 and 7. 1. Okay, and you're standing here at 7 and you have to go towards the negative direction 3 times. So you hop 1 2 3 and there you are, +4. So that's the answer. Okay, so that's another way of doing this. So then we come to the difficult one. Okay, and it's actually not the difficult one, depending upon how you look at it. If you look at it as a puzzle, then it seems like it's an interesting one, because you don't know now how to solve it, and you introduce a new method in mathematics. Okay, because mathematics allows us to do some interesting things. So what is that problem? The problem is when you have to subtract something which does not exist from a number. And strange as it may sound, that is possible. The third one. The third type of problem, and it's not really the third type of problem, I am saying it is the third type of problem. There are lots of different ways of subtracting integers that you yourself can work out. In fact, they say that there are so many rules for subtracting integers that it's a little absurd to actually list everything. You should just know some general ideas and then approach it from there. This is when you have, shall we start with a positive number or negative number?
Negative.
Negative, okay. Negative is always interesting. Let us say that I have got -9, right? And I have to subtract +2 from it. Okay, so here's when things start getting interesting. Why is it interesting? Is because, think about it. I have 9. I just keep count of things. Okay, I don't want to make a mess of it later. So your task is just to check the numbers and tell me if I've got it right.
It is 8 plus 8. You need one more.
No, I think I've got 9 because I've got 4 and 4 plus 1. That's right?
Right.
It's correct.
Sir, I also think you need one more.
No, not yet.
No, it's correct. See, I've got 4 and 4 and one more.
And one more for 9.
It's 9. Okay, no doubt about it for me now. All right. So I've got -9, and what am I supposed to do? I'm supposed to remove the operator +2 from this. But where is +2 in this? There is no +2. 2 is this, right? +2 is this, but there is no +2 over there. So how can I remove something that does not exist? Okay.
So you'll have to add the pairs again. The pairs.
I couldn't hear that. Speak a little clearly.
So you have to use the pairs method. You have to pair the minus and pairs.
So those who saw the activity the other day, there is a way in which you can do it, in which you introduce something called the pairs method. I think we have called it the pairs method. Somebody called it the pairs method. So I'm going with that. That seems like a nice word for it. Pairs method. Okay, but the thing is, before we get to there, let us look at it a little more closely. What I want to do is I want to remove 2 plus from this, but there is no 2 plus in this. So what do I do? Okay, if I don't have 2 plus, I can put 2 into this. But then that becomes something that is not allowed in mathematics. Okay, so this is not allowed. Why? Because every number has its own identity. -9 is something, right? It's on the number line. It is 9 divisions
-9.
0. So it has its own identity. It is neither -8, neither is it -7, nor is it +2. It's nothing but itself. Okay? And if you add something to it or you remove something from it, right, that number changes. Okay, and we are not allowed to change the numbers in mathematics because you change the whole sum when you do that. Okay, so therefore something that is not allowed, you are not supposed to do. But that's not the end of it. There are certain things that are allowed. Say for example, I want 2 over here, but I can't just put 2 over here. What if I put a pair like that? Okay, now what is the rules about numbers tells us? It tells us that there is the additive inverse. Do you remember that? Do you remember the additive inverse rule?
Yes,
No,
sir.
Okay, so let us approach it from that. If I add a number to this and I subtract the
Oh,
same
then I have
number.
to add the same.
Sorry?
So if you add one positive to it, so then you have to add one negative also to it.
Absolutely. So if you do that, well, that is allowed.
Sir,
Yeah.
Says Daham, can I explain what is going on here?
Why? What happened?
So because I know how to solve this, so can I explain a bit?
No, let me finish, then you can explain, give your explanation.
Okay, okay.
Okay, so when I do that, do I mess with this number? The -9, if I add one positive, but also one negative.
Yes, sir. -10.
That's perfectly allowed, right?
Still -9.
Yeah, it is still -9, isn't it? Okay.
Yeah.
So we use this rule, the additive inverse rule, to play around with the numbers in a way that is allowed. It's allowed because it is logical. Okay, there is nothing wrong with adding something and then subtracting something. So it's like saying, look, I need 200 bucks to buy something from the market. I have only 100 bucks, but I'm going to get a little bit money later on. Lend me 100 rupees and I'll give it back to you later. So when I borrow the money from you, I take away some money from you, but when I return it back to you, you go back to whatever you had earlier. So that is logical. If you borrow something, you have to return it. Similarly, if you add something and you subtract the same thing from a number, you don't disturb it at all. If you want to look at it in terms of the number line, I'm just going to go with -9, 3, 4, 5, 6, 7, 8, 9. -1, -2, -3, -4, sorry, -5, -6, -7, -8, -9. So you're standing at -9. Okay, and what I'm doing is I am adding 1 to you. which means I have to move towards the positive direction, because this is 0 and then you get +1, +2 and blah, blah, blah. So I add 1, which means I shift you in this direction. But then I subtract 1, which means I shift you back in this direction. You get it? So in the end, you are still left with -9, at -9. So there is no problem with that. But what this does, interestingly, for our sum is that it allows us to, without breaking the rules of mathematics, add 2 positives which did not exist before. Okay? Now what happens is that I can remove a +2 from there. So this is still -9. But I can now remove +2 from this. And when I do that, what have I got left?
-11. So -11.
-11, exactly. Okay, now I can understand that some of you might be confused with this. How can you do that from -9? If you remove +2, how do you get -11?
Yes, sir.
Look at the number line and think carefully about these 2 signs. This is what tells you in which what you're supposed to do. Are you removing or you're adding? And this tells you how many times you're doing that. So with the number line also it's possible, but I think with the number line it becomes a little confusing. It is best if you work it out on your own. Okay, so
Sir, I got it like +2 means we have to add that thing. And if it is -2, we have to subtract it.
no, don't look at this sign. Only tells you the sign of this number. The operation and the sign together tells you in which direction to move. It's not that straightforward with the number line. I'll allow you people to work it out on the number line and tell me. We will take up the number line method a little bit later. But this method, would you say that I did some fooling around with the rules of mathematics over there? Anything wrong that I did? Not logical? Something?
No, sir.
No, sir. There's nothing. You didn't do anything like that.
Exactly. So therefore, this is one way of understanding how you subtract integers when the positive number or the negative number does not even exist in that group, by adding pairs. Of course, you can realize that this pair adding method is something that can become a little complicated if you have large numbers. You don't do it with large numbers, you do it with small numbers. Like I said before, once you are clear with the rules, then what you can do is you can bypass the activity part or the number line part and just solve it directly with numbers. So now I see that there is a question from Vedika. Veer is asking if we should write this down. Not today, we don't have enough time to do the different numbers. So actually tomorrow what we will do is I will give you different numbers, different sort of operations to do. We have done it only with negative numbers. We can also do it with positive numbers. And then I will give you different sums that you can solve. Then we will become clearer about this. So you need to write it at that time. Today there is nothing to do. You can note this down, of course, but you don't have to submit anything today. And then Vedika, why and how can you do what? The adding pairs? I didn't quite understand your question. So maybe we will take...
Time is up.
Time is up now. So we will
Bye.
meet again tomorrow. Bye.
Bye, sir.
Bye, sir.